Hi guys, I am Devyanshu and welcome to my YouTube channel. So in today's video, we'll see the difference between shallow copy and deep copy. It is one of the very much asked interview questions in JavaScript. So in JavaScript, when we create a copy of objects and arrays, we get two types of copies. One is shallow copy, another one is deep copy. So in shallow copy, it creates a new object or an array, but only the first level of properties or elements. That means if there is no nesting, then it will work properly. It won't cause any issue. But the catch is whenever there are nested objects or arrays, only references to those nested elements are copied, but not the actual values. So if suppose we have an original object and we have a copy of it, and if we make any changes to the original object, then all those changes will also be reflected in the copied object because it is a shallow copy of that. But in deep copy, it completely creates an independent copy of an object or an array, and making any changes to the original one doesn't affect you know the copied object. So let's quickly see this in action. It might look a little confusing at start, but it is very easy and we'll try to simplify this in this particular video. So I have my code sandbox open. Let me clear this up. Yeah, let me consider a very easy object. Suppose I have A is 1, B is 2, C is 3, and I have a copy of it. I'll spread the original one here. Okay, original. Okay, cool. So now if I'm making any changes to the original one, right? So original dot b, suppose if I change its value from 2 to 12, then what will happen? See, so in original one, the value of b got updated to 12, but in the copied one, it is 2 only. So in this particular scenario, it doesn't have any impact, it doesn't cause any problems, right? Because this is at single level, all these key value pairs are at single level, there is no nesting here. But what if I add a nesting here? I remove b, value of b from 2 to I'm changing it to a nested object, right? So now b has an object with key value pair C and 3. Now, if I make changes to the object B, right? So then what will happen? See, in original one, we have A is 1 and inside B we have C is equal to 12. But in copied one, also we have C is equal to 12. But we made change only to the original object, but not the copied object. But in case of the single level, when there was no nesting, uh, whenever we made any changes to the original object, it didn't affect the copied object, right? So this is because of the shallow copy. So another way of creating shallow copies, one is, as I mentioned, one is the spread operator. The second way is if I create a copy of it using object.assign, that also create a shallow copy. So I'll use assign copy variable for that. Uh, my bad. Ob dot object.assign original, right? Now let's check this one. Assign copy. Okay. So what are we getting here? This is the original one, this is the copied one, and this is the assign copied one that we created using object.assign function, right? So all both of these are used to create shallow copy. So I'll just add here it in comments, shallow copy and shallow copy, right? Now how do we create deep copy of it, right? So we have two ways to create deep copy. One is to use a structured clone function, and another one is to use the JSON properties. So I'll show you both these ways, right? Ways to create deep copy, right? So one way is to use a structured clone, and in structured clone, what we'll do, we'll just simply pass the original object, and I'll console this one. Structured clone is not defined, so I'm not sure why. Ooh, did I? Ah, yeah, I made this mistake. No, it should work. Silly mistakes, my bad. Sorry, guys. Yeah. So now if we see this, see. So in this original one, it is 1, and B has C is equal to 3, right? And now we are making changes to the original one, right? So when we made changes to the original one, it didn't change anything in the object that has deep copy, right? It is same as the original one before making changes to the original one, right? Are you getting my point? See, the original one has C is equal to 12, but the deep copied one has C is equal to 3. So this is deep copy. Now another way to create a deep copy is, what we can do is we can make use of JSON properties. JSON.parse stringify original one. See, so what are we getting in deep copy 2? In deep copy 2 also we are getting C is equal to 3, which is as same as the original object before making any changes to it, right? In original we have C is equal to 12, but in deep copy 1 we have C is equal to 3. So these are uh, you know two ways to create deep copies of an object. So now let us quickly see why shallow copy behaves like that. So let me try to explain this to you using a memory layout. So see, so suppose we have this original object in memory at location 001, right? Now this contains one key value pair which is a is equal to 1. So it will have a value in memory, right? A space in memory. So and now B contains C is equal to 12. So B has a nesting here. It contains another object C is equal to 12, right? So rather than storing the this particular value, it will store the reference of it. So suppose it has reference 002. So yeah. So now suppose this B has memory location 002. Now what will this contain? This will contain C is equal to 12. Now this will contain a space in memory, right? It will directly point to the value of C, right? Because now there is no nesting, because if we consider this particular object, then there is no nesting, it is linear only, right? Now suppose we have now we created this copy of this, right? This shallow copy of this. So when we create, let me mention shallow copy. So when we created a copy of this, then this particular copy object will also get a space in the memory. Suppose it has a memory location 003, right? It has memory location 003, and here a is equal to 1 will get a new memory value. This will get a new memory value because I explained it to you, right? When it is linear, then the actual values are copied. The catch arrives when we are talking about the nested ones, right? And now when we have B as now when we come to B, then in B again it refers to the same memory location. It has reference of 002. So now it will again point to this particular B object. So whenever we make change to this original one, then it will also reflect all the changes in this shallow copy one, right? So this is why the shallow copy behaves like this, right? This is why when we make any changes to the original object, then the changes get reflected into the copied object as well. But in case of deep copy, it is not so, because in case of deep copy, this A and this B, both of these both of these get new memory value, right, in the copied object. So this is it in this particular video. So you can try the same for arrays. It is very simple. uh, I'm leaving that for you. So if you like this explanation, uh, like this video, do subscribe to my channel. Thank you.